Hello everybody, my name is Borno Isaac Berry from Berry Science Lab.
Excuse me, Hoa. Hoa is Chinese, right?
I said hello.
Or Hola or which one?
Hello.
Okay.
Are you being hypnotized by the Chinese flag in the background?
Sure.
Okay. 59. Let
Here's the problem.
Z30 be the ring of integers mod 30, which means you just have 1, 2, 3, etc. 30. And then when you try to add 1, 31 maps back to 1, 32 maps back to 2, and similarly, if you have 61, it maps back to 1, 62 maps back to 2, and so on and so forth. Which means that, for example, 31 multiplied by 2 in this system is actually equal to 2. Pretty crazy, right? Not that crazy because this just maps to 1 times 2. So, let U30 be the group of all invertible elements in Z30 under multiplication. Now, what you can find out is that those elements are actually 1, 3, 7, 11, 13, 20, 17, 20, 19, 23, and 29. These are the elements that are invertible, which means there is an element that you can multiply them by that gives you 1 in the set. Like, for example, 1 multiplied by 1 is, of course, 1. 3 multiplied by... Is 3 in this set? Oh, yeah, it is. Wait. Is it? No, it's not. For the same reason, 13 is in the set. 11 is in the set because 11 times 11 is 121. 19 is in the set because 19 times 19 is 361, so on and so forth. You can form some integer below 30 multiplied by this number such that it's equal to 30 times some integer plus 1, which is congruent to 1. Alright, we're getting sidetracked. Let phi be a group homomorphism. What does that mean? It means it's a bijective, one-to-one and onto, map from the group onto itself. From U30 to U30, with the kernel being 1 and 11. What's the kernel? In multiplicative groups, which we're dealing with right now, the kernel is just every element n, or k, such that phi of k is equal to 1. So if phi of 7 is equal to 7, which of the following elements does phi also map to 7? A group homomorphism has one special property. In multiplicative groups specifically, phi of AB must be equal to phi of A multiplied by phi of B. Now the fact that 1 is in the kernel is pretty obvious. I mean, phi of B is equal to phi of 1 multiplied by phi of B. So naturally, phi of 1 has to be equal to 1 to make everything make sense. So what about 11? That's what really helps us. We know that phi of 11 multiplied by B is equal to phi of 11 multiplied by phi of B. And since 11 is in the kernel, that means that phi of 11b, this just goes to 1, and this is just phi of b. Now this is what comes in handy because we know phi of 7 is equal to 7. So that means phi of 77 is also equal to 7 by this rule. But wait a second, 77 is equal to 60 plus 17. And 60 divides 30. In other words, the remainder when you divide 77 by 30 is 17. Which means that since we're dealing with mod 30, this is also equal to phi of 17. Which means, by transitivity, phi of 17 is equal to phi of 7, which is equal to 7. Which means the answer is C, And as you can see, if you scroll down to see the answer key, it is indeed C. So that's it. Thanks for everybody for watching, and we'll see you in the next one.
Keep going, keep going.
Wait, what?
Oh, you done?
Yeah.
Oh.